Alright, so we're going to be looking at solving by graphing and solving if there's a table. Alright, now if we're solving by graphing, we're simply going to have two lines that are graphed, and we're going to try to figure out where they cross. The solution is always talking about where a specific set of lines cross. So if I graph two equations, the place where they cross is the solution to that system of equations. So I want to figure out where exactly that is. Now remember, when we are solving a system of equations, we start from the origin, which is the middle of the graph, and I'm just going to count until I get to the exact point where they cross. So I'm going to go to the right 1, 2, 3 spaces. So the point where they cross is at 3 on the x-axis, and I'll go up 1, 2, that's at 2 on the y-axis. Those are both positive directions. That is the solution to those two systems of equations. That's where those two lines cross. Okay, now if it's on a table, it's actually much easier. I'm just kind of trying to match and see what these two graphs have in common. Now you'll notice that this graph has the point 3 on the x, 2 on the y, and so does this table. So these two tables have a common point. That would be the solution. Whatever they have in common, you're just kind of trying to look and see what those two tables have in common. So if they're asking for the solution on a graph, I'm figuring out where they cross. Okay, that's a point on that graph that both of those lines actually share that point. Well, if it's on a table, it's the same thing. What ordered pair do they both contain? This is where these two functions, these two lines would cross. Okay, and that is how we would solve by graphing. That's how we would solve if we had a table. Either way. And I'm just going to where that solution is. So if I had a graph, let's say this was my graph, I always start from the middle. Here I would actually have to go left 1, 2 spaces. If I go left, that's a negative direction, and then I go down 1, that's another negative direction. So that would be the solution to these lines. I'm just looking for the specific place where those two lines cross. That's the solution. Alright, so there are three types of graphs that we want to get familiar with. That, really the only thing that you're typically going to see are you're going to have lines that either cross at a specific point, like this one does over here on the left. It crosses at a specific point. There's one solution. Or you're going to have lines like these in the middle right here. They are on top of each other. These lines, these are two lines that are graphed. They're the exact same line. This is what we call infinite solutions. Okay, now if there's just one solution, they only cross at one place. But these two lines here, they cross everywhere. I mean, they don't even actually cross. They're just on top of each other. Alright, so these lines have infinite solutions if they're on top of each other. They're basically the same line graphed two different times. Or you're going to see these graphs here where the lines never cross. Okay, this is what we call no solution. If the lines are parallel, they have the exact same slope, there's no place where they're ever going to cross. They're just going to go on forever, never make contact. That's what we call no solution. Okay, and that is what you're going to expect to see when we are graphing systems of equations.